Hey guys, hope everybody had a good spring break. We've definitely missed seeing all of you in class, but hopefully you're enjoying some time at home, hanging out with family, not going stir crazy quite yet. Today's lesson, we are going to review the last thing we did before spring break. So if you remember back to last Thursday and Friday, we were talking about predicting products in double replacement reactions. So when we looked at the understanding check from the double replacement reactions, we decided that we probably needed another day of practice with this. Some of us got it right away, no problem, but there were definitely some shaky understanding checks. So we're just going to throw in another day of review with some additional practice to make sure that you're really getting this before we go on to the next step. It's pretty important for what we're going to do moving forward, so it's kind of a big deal. It's an important skill that we want to make sure that you get. So what I have here on the paper in front of me are the two reactions from our understanding check. We're going to take a couple of minutes to go through those, show you how those two reactions work, how we go about that. I've also written over here in the corner a shorthand version of the steps that were on that PowerPoint from last week. So I'm going to continue to reference these as I go through these two equations. After we're done going through the two understanding check equations, I'm going to go over one more from page 18 that'll give you one more example of what we're doing. And then the rest of the lesson, you are going to work on page 18 and page 19. You've got some practice problems there. So I'll show you those before we are done here. Okay, so if we look at these reactions, the first thing that we said we were going to do was figure out our oxidation numbers on our reactant side. So if I look at the first example here, I've got a periodic table out. If you don't have a periodic table out when you're doing these, probably would be a good idea to get one out unless you have all of your oxidation numbers memorized. So I'm looking at this. I know that potassium has a +1 charge. So I'm just going to write that down here so that I remember that. I also know CO3 has a -2 charge. If I had forgotten that, I knew that there were two +1s attached to that CO3, so that would also clue me in that this has to be a -2. Over here, barium is a +2, and chlorine is a -1, okay? So anything that's not a polyatomic, you can figure out those oxidation numbers from your periodic table. If it is a polyatomic, like carbonate here, you either have to have that memorized or you have to rely on whatever it's attached to. In this case, potassium is the cation, so I can use that, the number of those, help me understand what the oxidation number is. So that was step one. I had to figure out what my oxidation numbers were. Step two is that I'm going to switch the cations. So what that means is on this reaction here, I'm going to take this potassium and barium and I'm going to have them switch places. So when I write the products on this side, I'm now going to have potassium chloride. So I took this cation, put it with this anion, and then I'm going to take this cation, barium, and I am going to put it with my carbonate. Okay. Notice the only subscript, the only little number that I took with is the 3 because it's attached to a polyatomic. So my subscripts that are attached to polyatomics have to come with, but none of my other subscripts are going to come with. Okay, so this 2 that was attached to the potassium, that didn't come, and this 2 that was attached to the chlorine, that didn't come. Okay. From there, my next job is to balance the charges. Okay, so those are the same oxidation numbers that I looked at before. Remember, potassium is still a +1, that's the same as over here. Chlorine is still a -1, that comes from right here. Barium is a +2 from right here, and carbonate is a -2. So in this case, my charges are already balanced, so I really don't have to worry about it here. They just happen to be balanced from how they paired up, okay? So that means I'm not going to include any more subscripts. When I'm balancing charges, I use subscripts. When I'm balancing the equation, I use coefficients. If that is confusing to you, that's a note that you should put in your notebook. When you balance charges, you use subscripts. When you balance equations, you use coefficients. Okay? So now I'm on to step 4. I'm going to balance this equation. Okay, so now I'm looking. I have 2 potassiums on this side, which means I need 2 potassiums on this side. I have 1 carbonate on this side. I have 1 carbonate on this side. I have 1 barium on this side, 1 barium on this side. And I have 2 chlorines on this side. And now with this coefficient here, I have 2 chlorines on this side. Okay? So now my very last step is to determine the solubility. Okay? So this is where I'm going to use those rules that I took down in my notebook before spring break. I believe that was on Wednesday we looked at the solubility rules. It was our first virtual lesson. Okay? So those are something else in addition to your periodic table that you're going to want to have out when you are predicting products. Again, unless you have all those solubility rules memorized, that's going to be important to have out. So in this case, I know that potassium chloride is going to be soluble. So that means it will dissolve in water. It will make a solution. Okay? So I label that as aqueous. And I know that my barium carbonate, that's going to be insoluble, meaning that it won't dissolve in water. So that one's going to be labeled as a solid. Okay? Again, I use those solubility rules that I have written down. You have them in your notebook, so you should use those when you're predicting your solubility, the last step. Okay? Let's look at this next example. This was number 2 in the understanding check. Okay? So we're going to follow these same steps. I'll try to get it so that you can still see those steps and you can see the reaction here. Okay? We're going to follow those same steps that we just did for the one above. So I have a cobalt hydroxide and I have HNO3. Okay? So we're going to go with HNO3. We won't deal with the other name for it right now. That's something that we'll talk about more when we get to acids and bases. Okay? So right now we've got cobalt. We know that cobalt is a transition metal, so that makes it a little bit more difficult to determine what its oxidation number is. We have to rely on what it's attached to. So in this case, it's attached to hydroxide. We know that hydroxide has a -1 oxidation number. That's one of your polyatomics. Hopefully you have those memorized. If not, make sure you've got a list of those out as well. So you might need a few things as you're going through this. So I know that if my hydroxide is a -1, and I have 2 of them, whatever this charge is, it has to balance out with a -2. So this must be a +2. Okay, remember I have 2 -1s. I know these charges have to balance out, so that means I have a +2 to balance out with my -2. Okay. Over here, I have HNO3. H is a +1. NO3 is a polyatomic. It's a -1. Okay, so I've taken care of step 1. I've determined my oxidation numbers. Step 2 is when I'm going to switch my cations. So in this case, cobalt is going to go with nitrate, NO3, and hydrogen is going to go with my hydroxide. Okay, so I've switched my cations. I put this H with this OH, and I put this CO with this NO3. Now I need to balance my charges. Okay, so I know these same charges are going to apply on this side. So I know cobalt was a +2, it's still going to be a +2. I took that right from here. I know that nitrate was a -1, it's still going to be a -1. Hydrogen was a +1, and hydroxide was a -1. So up here in this example, we didn't have to worry about any subscripts because they were already balanced. We don't get so lucky here. If you look at this one right here, cobalt and nitrate, cobalt has a +2 and nitrate has a -1. Okay? So in order to balance those, I'm going to need 2 of this -1 to balance out with the +2. So to get that, I have to take this NO3 and I need 2 of them. So normally I could just put in that subscript, but because this is a polyatomic, I have to put parentheses around it. That tells me that I want 2 of this entire polyatomic, this NO3. Okay? So now I've got 2 times a minus 1, so that would be minus 2 here. I've got plus 2 here. I have plus 1 here and minus 1 here. So my charges are now all balanced. The next step is then to balance the equation. Remember, you balance charges with subscripts. You balance the equation with coefficients. So if I look at balancing my equation, I have 1 cobalt on this side. I have 1 cobalt on this side, so they're balanced. I have 2 hydroxides here, but I only have 1 hydroxide here. So I'm going to go ahead and put a 2 in front of this. I have 1 hydrogen on this side, but 2 hydrogens on this side for this 2 right here that I just added. So I'm going to put this 2 in front on this side. So now I have 2 hydrogens on both sides, and that works out because it now gives me 2 nitrates on this side. And I also have 2 nitrates on this side because of my subscript here. So now I've balanced it. I've used my coefficients to balance the equation. My last step is to determine the solubility. This one's a little bit trickier. We know, obviously, water, it's soluble, right? Water dissolves in water, it's water. Okay? So because water is a liquid, we're actually going to label it with an L. Okay? Aqueous, remember, means that something is dissolved in water. This is water itself. I also have this cobalt nitrate. Nitrates are soluble, so this is going to be aqueous as well. So we don't have any precipitate here in this equation. These are both soluble. Okay. So let's look at one more example. We're going to look at page 18. We're going to look at number, well, I guess it's letter A under part 2. Okay. So we're looking at this one right here. The rest of this page and page 19 are going to be your work today. So this is what you're going to work on for a little bit of additional practice. Notice it also includes that precipitate color. That would come from your notes on the solubility rules. There was a little slide in there that gave you certain colors that some well-known precipitates have. So that would be good to have out in those notes as you're going through this. Okay. So we'll look at this last example here, part A under number 2. For all of these, you don't need to worry about the spot that says net ionic equation. So you can go ahead and cross those out. That's just something that we're not going to deal with. It's another way of writing these equations. It takes some things out. We're just going to not deal with it while we're working on this. So we're just going to deal with the balanced equation and then use our solubility notes to determine the color. Okay? So one thing that makes these just slightly more difficult, we're going to review a little bit of naming. You've got here your reactants, but they're written as words, not as the symbols. So you're going to have to take those and turn them into symbols. Okay. Our first one that we're going to look at is iron 2 sulfate and sodium hydroxide. So if we look at this, iron is Fe. I can get that from my periodic table. 2, remember, means that that's the charge. So I'm going to come back to that in a second. But I have iron 2 sulfate. Sulfate, remember, is SO4. I'm mixing that with sodium hydroxide. Okay. So you can see where polyatomics are going to be a huge part of this. In this example, we've got 2 polyatomics. We've got a sulfate and a hydroxide. So if we remember these steps that we had before, I'll see if I can pull these back out for you again. Okay, here are our steps. Our first job is to determine the oxidation numbers. Okay, so this is also going to be important to make sure that we've written our subscripts correctly on the reactant side. So we're going to check that as well. So if I'm determining oxidation numbers, I've got iron here. Remember, that's where this 2 comes in. That tells me that the charge on this iron is a +2. The charge on the sulfate, I know because it's a polyatomic, is a -2. Over here, I've got sodium hydroxide. Sodium has a +1 charge. Hydroxide has a -1 charge. So I've written my 2 reactants correctly. I don't need to add any subscripts. They're balanced already. So now step 2 is to switch my cations. So that means this iron is going to go with the hydroxide, and sodium is going to go with sulfate. So from there, iron hydroxide and sodium sulfate. I now need to balance my charges on the product side. So the same charges apply as did on the reactant side. So iron is a +2, hydroxide is a -1, sodium is a +1, and sulfate is a -2. +2, -1. In order to get those to balance, we need 2 of these. +1, -2. In order to get these to balance, we need 2 of these. Because I'm balancing charges, I can use subscripts here. Notice these subscripts aren't on this side, so I didn't transfer them over from the other side. I just used them here on the product side to balance my charges. My next step then is to balance the equation. 1 iron, 1 iron, 1 sulfate, 1 sulfate, 1 sodium, 2 sodiums. That 2 in front. Now I have 2 sodiums and 2 sodiums, and I have 2 hydroxides and 2 hydroxides. So I'm now balanced. My last step is going to be to determine the solubility. Again, using those solubility rules. As I look at the solubility rules, most of my sulfates are soluble. So that's going to be an aqueous here. Hydroxides, iron hydroxide is not soluble. So this is going to be my solid. There really isn't a trick to solubility rules, guys. You just have to use what you have written in your notebook. When we assess those, we'll give you a list of solubility rules. We don't expect you to have them memorized. You just need to be able to know how to use them. So you have to make sure that you have them out and you're using them as you go through this. Okay. Remember we said that there's that other part here, determining the precipitate color. So again, that comes from your solubility rules notes. In this case, we said our precipitate is going to be our solid. That's our iron hydroxide here. So this iron hydroxide, iron makes things orange. So our precipitate color is going to be orange. Okay. So that's officially the end of this lesson. Here's my recommendation for you. If you're feeling good about this, go ahead and finish B and C on page 18. And then on page 19, you've got D, E, F, and G. Those answers are going to be posted on the next slide in the PowerPoint. If you are not feeling great about this, remember there are office hours both in the morning and in the afternoon. So please take advantage of that. Come online, talk to one of us, either Mrs. Ottemeyer or myself. We would be more than happy to work through some of these problems with you, answer any questions that you have. I will tell you that the more that you practice these, the easier they get. You get into a pattern, you figure out how to follow those steps, and they get a lot easier to do, but they do require practice. So if you've been watching the videos, but you haven't been taking the time to do the practice, and you've just been skipping right to the understanding checks, that's definitely going to catch you. It's probably going to be a lot harder than if you practice and get good at it. So I would absolutely recommend doing the practice, making sure that you get those done, asking any questions that you have. Tomorrow we are moving on to the next step. So it's going to be important that you've got this down by tomorrow. We're going to keep building layers on this. We're going to keep adding to it. So if you miss a step, if something doesn't make sense and you just hope that we don't come back to it, you are going to get caught. So pretty please make sure that you have a good understanding of this. If you don't, take the time to talk to one of us during our office hours. That's what we're there for. We want to see you. We want to talk to you. We want to make sure that you're getting this. Okay, hope you have a great day. See you later.